Here's a fun one. Let's get our fuel filler door converted to an electric charging door. And by the looks of it, it's going to be a perfect fit. EV West also sells a conversion plate, something like $17, and you get a machine cut opening that's going to fit our charging port. And then this is our template, sort of, for what the Volvo setup is. Template's more or less made and traced. Now it's time to cut it and drill it. Yeah, it's a good thing we checked. Look at that, it's butting up against the top. We're gonna want to drop that boy. EV West has a very nice guide for the J1772 best practices. This is a very useful bit of instructions, and the first step that I did here is to take this apart. Once you take it apart, you get to the pins. The pins are pretty hefty. Got the big boys, 3 of those, and 2 small ones. And now we're going to talk about the Elcon HK-J series 3.3 kilowatt sealed charger. This guy has a lot of options, a lot of wires. What's going on? How does it connect? And why isn't this stuff really described in the diagram? Our wiring diagram gives us some idea of how the J1772 port is going to wire itself to the charger. We see that it goes to the white and black and then the green. And those colors correspond over yonder here. So what's on the end of this? It's our wall plug. So this is the input side of the charger. This is where the power comes from the house or from whatever charging port. In this case, it's set up to an extension cord style. And that's going to be 220 volts AC, 3300 watt. Or if you plug it into 115 volts AC, you get a 1600 watt charge. It's not very practical, right? Because we want to go with our fancy J1772 that we've taken apart here. So we're going to cut this. Bada boom. We'll have the 3 wires, the green, white, and black, and those will be right there and connected to the J1772. So we'll be able to use our high voltage. Now, in theory, you could order another one of these connectors here and essentially go back and forth between how you want to plug it, I think. I was considering that, like, what if we just didn't cut this? What if I just got another mating female end connector and then wired that up to the high voltage charger? There are 5 wires coming out of this port, and we have the pins laid out here. Those guys are all going to be communicating to the car in other ways through the AVC2. Got a little more research to do on the AVC2 to figure out exactly how it works, but essentially our 5 wires include these 2 small ones here, which is pilot signal and proximity signal, and those end up communicating from this unit. So back to the charger. The charger has, on the other side, 4 different ends, and this is how they came from the supplier. Output range on this series of Elcon chargers can go between 50 to 198 volts. Our car, 144 volt system. I think our batteries are going to cap out at a certain voltage around there. But I gave all the information to the guys over at Evolve when they were supplying this charger. Normally I would have ordered it through EV West, but they only had the CAN options because I wanted a non-CAN. Now, the big question to CAN or not CAN is determining how much you want to program your own charger. If you get a CAN bus charger, this port here with 4 wires will have an output of 4 wires. If we go to the wiring diagram on the last page, we see that we have plus 12 volt, minus 12 volt, CAN high, and CAN low. So I gave them the specifications and they said, okay, we'll pre-program your charger, we'll disable the CAN. So we have then added this wire, which is a little blue and white wire that goes over yonder to the bag. And the blue wire that has been added goes to this little single pole connector. And that one's actually going to reconnect right back here on the other connector. So the green wire we see from here is the enable for non-CAN. Then we have 1 and 2 on the other connector, red and black, which is temperature probe for lead acid. I don't think we're using those. And then the AVC2 controls the on-off part of the switching circuit to charge the thing. All right, I think that makes sense. There's also a 3-wire connector here. I have no idea what this is. That's the 3rd one coming out of this side, and it does not make an appearance here. A little frustrating, but we're gonna go ahead and presume that it's not needed as well. And last but not least, the big boys, the plus and minus. What's a little frustrating about this guy is that you look at it and you go, okay, well, maybe that's low voltage because it's not orange cabling, but these are actually the two cables that are going to run back into the contactor box and ultimately back into the traction pack and supply power to our batteries. So that would be these two wires here. On our diagram, they're orange and orange with black all the way through, but this is the red and black connector, and it's going to run to a 30 amp fuse. So the drawing of this fuse is a little different than the one we have in the car, but essentially those wires are going to run through. One goes to the shunt, the negative side, with all the other accessories like the DC to DC converter and the high voltage cabling going back to our controller. But then the other one's going to go and get fused 30 amps and into the main contactor on the number one side, which is very important that we keep the contactors 1 and 2 or plus and minus side. It's hard to say plus and minus because while you see that the colors that are red and black, the left and right side does matter for current flow, but it's not really negative. It's more of like input-output side. I think that's it for the wiring. Okay, that wasn't as daunting as I thought it would be. The next thing is positioning this guy because we want it to be somewhere where there's adequate airflow. It can cool itself and it's not going to be struggling. I like that it's got these holes here. So what I think I'm going to do is have it flush mounted with our rear panel, which at this point is this shiny black plastic. So in here, once the BMS stuff is all figured out and the battery box is pushed in, I think that charger is going to have enough space to live right here and probably stick out this way. Our shopping list of cables here for the J1772 is going to require 10 gauge in 3 colors, green, black, white, which we're supplying from here. 18 gauge purple, orange, which can be changed to whatever color you want, but I like to stick to the diagram the way they set it up for us, and then a 14 gauge green. I've got that ready to go. The 2-conductor 20 wire in the gray sheathing here, it's the 12 volt positive and negative. I thought it was coming into the charger to power the fan, but it's actually an output. So the charger supplies 14 volts on this wire for something. I don't know exactly yet. I've started to draw a schematic here, which helps me kind of wrap my mind around the various options that we have, because this is very useful on its own, but it doesn't really show me how to integrate it completely into the entire system. And this is useful too, but it's missing a lot of the smaller wires on a charger. So this diagram also does not include a lockout relay, like a safety relay or a buzzer or any of that stuff. So that kind of gets into the advanced mechanics of an EV build. Our J1772 is looking pretty stable here, but one of my questions is, it's a 14 gauge wire here. The stuff that came out of our wall plug there, this is just 14 gauge. It's a 314, and then the stuff going into the charger is also a 314, but EV West instructions say to use 10 gauge for the big 3, or the green, white, and black. And that's basically the AC voltage going in. And the input current says that it's rated for 16 amps, which is why they've put 14 gauge wire here. The EV West instructions for 10 gauge are, I emailed them and they said it's just, you know, if you're going to go with a larger current, you're going to want the 10 gauge. I think that's like 20 to maybe 30 amps, 32 amps or something like that. This smaller gauge is what is supplied from the manufacturer. So if the maximum output current limitation is 32 amps, that might be more than this 14 gauge wire can handle. I think 14 gauge is pretty much standard for like extension cords, and that's like a 15 amp constant load. So I'm not sure what that's about, but if it says 32 amp, it says 32 amp. You know, kind of like how some car circuits are 20 amp fuse, but the wires are pretty small, and you're like, when is this ever going to see a 20 amp current? We're pulling 110 volts if you plug it into the house, but if you do a 220 volt, you can get 3,300 watts of charging current on this. That's really great, charging power. So that's kind of cool. We've got the 10 gauge wire coming out of our unit, so somehow it's able to send out 32 amps, even though it's taking in only 15. There's some sort of magic happening here. But I'm going to, through confirming a couple of things, I'm just going to go ahead and proceed with cutting the extension cord that was supplied with our charger so that we can hook this up to our J1772. Let's go. Step one, strip the wires. I've got them all set to the correct lengths here. The big 3, it's going to go 7/16, so it's kind of short on the green, and then it's long. It's 1 1/8 on these guys. They're going to get folded in half like you see here in step 2, but the green shares with the second green. This long boy here, which has been stripped for 7/8, and that's going to get folded and all attached together. The smaller wires, I don't have purple and I don't have orange, so I'm using blue and red. And I will, of course, update my own diagram that I make for these things, because I've seen various colors on different builds. So, you know, as long as you know what you've got, keep a note of that. And then the next step is to put them into these pins that have been drilled out into this 45 to 65 degree angle here. And we're going to put the weep holes facing up, fill them with solder, and once it starts coming out of that witness hole, we'll know we have enough. We can remove the heat. Bada boom, make sure that the solder does not interfere with the pins, and then add some heat shrink to them. So I'm gonna do the heat shrink now before they get too tight to slip over. All right, now we can attach the pins inside of the connector. It's just going to look like this. This is the exploded view. This failure goes there. And one thing to keep in mind, there is a skinny pin versus the 2 larger ones, and that's where the 2 green wires go. You can see it's a little bit thinner than the other 2 pins here, and a little bit longer. That's our PE terminal, which is the bottom of the plug as we're facing this way. Just pop them in, tighten it up, make sure that they're all waterproofed with this guy, and then that's on to mounting it. I've got my foam roll here, which is going to be very useful, and I painted the adapter plate, which means it's going to blend in nicely with the car once it's all installed. I forgot which side it was, so I painted both. Well, just one spot of bad news here, failers and failettes. It's easy enough to get the pins through the rubber here because silicone will stretch nicely, but the other end of that is this final retainer, and guess what? There's nowhere in the instructions that says that they won't go in through here, because the way it's set up, they're assuming that the back end of your wires isn't part of a pigtail like I have. You know, this pre-made extension cord, which is already sleeved into this vinyl, and they say just put the pins through and push the wires through. Can't do that, so I'm gonna have to unsolder these to get the connectors through, because there's no way to get them through the backside. I mean, there is, but that would require cutting up the entire loom, which I am growing kind of fond of. 2 steps forward, right? 1 step black. Okay, it's coming along nicely. That's looking better there. Look, we've got all the wires fed through, the big bulk of it down here, and I got 2 more connections to make. Let's solder. Turn the weep hole. There's a few strands that don't fit because my wire is 1 gauge size too big. And feed me, Seymour. Solder's coming out. And clean up the rest, hold it in place while it dries, cools. Got a little ugly looking with the extra strands, but nothing that a little heat shrink won't solve. So as funky as this end looks, the important thing is that this front part is nice and clean and straight, and it will seal against the waterproof silicone portion. That's everyone. And now all of our connections are soldered. Making sure that the rubber seal is in and all around. We are ready to tighten this up. Next thing. The waterproof gasket. A little silicone spray will make our lives go a lot easier. Seat that all the way in. Makes full contact at the bottom. It leaves the holes open for the screws. Nice. We're using a very tiny Torx 10. Nicely torqued all around. Pull the slack on some of these longer wires. And get everything bundled up evenly. And when it's all together where I like it, just give it a little overlap. Everything needs to taper right towards the middle because that's how this is going to fit. Let's go ahead and give it a nice spinny-maroo. Look at that. Closes up nicely. Pokes out just a little bit on the end here, but we can add a second piece of heat shrink. Now with the loom in place, we have ourselves a completely ready piece. This guy is ready to attach where the old filler neck used to be for the car. So instead of gas, we're now plugging in the electric port. And this guy is ready to plug into our charger. These 3 wires here will run to the AVC2, which is part of the charger circuit, and it controls a bit of the activation on and off of the charger, as well as communications. EV conversion diaries. It's time to connect the motor with the controller. Things are getting interesting now. It's time to seal up the rear box, which means I've got to create some sort of strap mount for it so that it can bolt to the frame of the rear seat. It's got brackets for the floor, and it has guides for the floor as well. So it's pretty secure, I think, once it's all kind of going to be put in place. But I'm going to be attaching the cables, which means that they're going to be energized. So I'm going to check all of my connections downstream. The front box is still out of the car. It's at my feet right now because I'm waiting on those brackets. Once the brackets are in, I can put them across the frame rails of the car, and then I can add the box on top of that, and it's going to sit on top of the Hyper 9 motor. It's too bad it covers the motor. It looks really pretty with those 3 phase leads in there. But it's time to, yeah, probably break out those heavy, high voltage rubber gloves pretty soon as we get into making these final connections. And then pretty soon it will be time to power up the system. But there's a lot of little cabling. I got to put power to the BMS. I got to put power and grounds and make all the connections for the J1772. And I have to install the charger and wire it up as well. We have major connections made to the charger, but not the charger mounted to the car itself. So there's lots of little things. It's this whole order of operations. I'm just trying to keep track of my check mark boxes as I make progress. I had to pull the batteries out once again because my plastic panel below, this guy, had some imperfections from the batteries and it wasn't letting them sit all the way down. And one of the symptoms of that is the battery not being low enough here, which meant that that black topper wasn't going to clear with the lid of the box. If you get a straight edge across, just make sure that your batteries are all kind of evenly gapped, meaning that they're seated down into the channels as far as they go. The batteries also have eyelets on the other side here where there's just divots cut in. The other side they have eyelets, and the eyelets are a little bit taller. These divots are about, I don't know, 8 millimeters, and the eyelets sit about 13 millimeters, and our plastic cover is about 13 millimeters approximately. So those eyelets don't have to be filed down. In some battery box configurations they do, but if I did that here, it would put more weight on this, so the eyelets are kind of in their intended location. Or is this battery upside down? No, I don't think so. I think it's right side up because that gives us the breakout boards, the PCB boards further up, better access for my fingies to get in there and plug them in. So it's all plugged in, it's all hooked up. I'm gonna keep the little desiccant bag at the bottom because that's gonna help with any moisture that might get in the box or condense inside of this thing. It's pretty sealed up otherwise. There's a little bit of like an air gap that'll happen naturally through the contactor, not contactor, but the little like plug there. And then I'm gonna go ahead and hook up the BMS once the box is in its final position there. And I wanna take careful note of the wiring here. Just take a photo of it. Boom. Cool. And now it's time for the lid. Finally. I want to put the charger on the left side of the battery box. And to do that, I want to make sure that it's going to be kind of flush with that panel that we have, but the cooling portion of it, the heat vanes and the fan, are exposed. So I'll make a rectangular cutout in my back panel. And this is the template that I have so far for it. And you put that in place. It'll sit a little bit lower than that, but essentially it goes just between the hinges and there's enough space for the hinges. The light won't interfere. It's all very nice. These strings signify the plane, which I am gonna essentially try to get this guy to sit up against. So it'll be something like that. I just got off the phone with EV West. Michael was nice enough to help me with a few questions about how to wire the AVC2. This little guy, it's a controller that controls the proximity and the pilot signal from the J1772 port. Apparently these J1772s can detect your thumb on the switch, so it cuts power off when you're ready to disconnect it because it doesn't want to have power running through it when you pull the J1772 out of the charging port. Makes sense. And in addition to that, there's a lot of wiring and triggers and relays and different bits and bobs that I noticed from some of the wiring diagrams. I'm going to walk you through all of that. It's going to be a lot of information, but I hope you find it useful. So in this diagram, it gives you some of the basic operations of the J1772's control board, the AVC2. The AVC2 has a relay inside of it. The interesting thing that I found is that this wants a chassis ground with this pin here through the green wire. And I called and said, it's interesting that this is the only place in the entire system where the high voltage from AC power is mixing with the DC voltage via the ground on the chassis of the vehicle. What's going on with that? And Michael said, well, it's weird, but it's necessary because this needs, if you think of your car kind of like an appliance, the power from the house just needs something to help ground it. So some of the charging circuits, it matters to them that you have this ground. There is another version of this called the AVC1, which is just the board minus the plastic housing. The plastic housing is what makes this the AVC2. There's also an AVC2R, and the R is for a resistor. That's like a 2.7 kilo ohm resistor that is quoted in some of these. The resistor lives between the ground and the proximity pin. It's built into the module and would be used in some cases, but I asked Michael about it and he goes, I've never used one and I've probably sold more AVC2s in the world than anybody else. So that's fine. We don't need to worry about that. As far as mounting the AVC2, it's got to live inside the contactor box because we want to put everything that's serviceable and that could fail in 10, 15 years inside of one box so that nobody's hunting around the car for it. You want to cram all of those replaceable components into one place. Well, we went through and noticed that if you look here, the AVC2 and the J1772 are there. There's this overcharge lockout, the blue wires, which run over to the state of charge meter. So our TBS Expert Pro was interrupting the power source to the AVC2. It was acting as the overcharge protection. Another name for overcharge protection is high voltage cutoff. And I found another diagram from EV West that describes the high voltage cutoff, and I noticed that this is because here we have the dilithium BMS primary controller. Our battery management system is not included in this diagram. So I asked about that and he said, yes, this is an older diagram. This is before we were using BMS. Think of the BMS like an airbag. We had cars without airbags and they worked just fine. The airbag is a safety feature. The airbag is there to add protection. So the BMS is there in case of a problem. If you need your airbag to protect you from your battery overcharging or your battery being depleted by undercharging, you're driving the car too much, you need to have a signal that gets sent out for that so it can warn the driver you're doing damage to your battery pack by running it close to zero. Or if it gets really, really hot and there's thermistors in our battery, if you remember those as we wired them earlier, those thermistors can be signaled through a message in the BMS to tell you your battery's overheating. Take it easy, stop driving, things like that. So this is the diagram for all of that goodness. And thankfully EV West has incorporated most of it, but it uses here no fewer than 3 relays and 3 diodes. Pedal interlock relay, low voltage cutoff relay, high voltage cutoff relay. There are 2 wires for these, but it's described as a loop. I asked him about that and Michael said that it does come up a lot, that it's a loop because we are sort of interrupting the signal for something to engage. For example, my charger, the charger that I have is a non-CAN charger, so it's fully set up to mate and match with the full traction pack voltage. So it knows when you reach 80%, you're going to start tapering the charge down to a lower, more acceptable rate so that the lithium-ion batteries are happy to get to 100%. Now that extra 20% takes a lot of time, and that's why a lot of car manufacturers, when they talk about your recharge times, they go, oh, you can get a 0 to 80% charge in under an hour, and then the 80 to 100 will take over an hour for that extra. So anyway, our non-CAN charger, since we're not using CAN bus to trigger the on and off, it's preset and it just has a single 12-volt trigger for it. And as soon as it sees 12 volts in that trigger, it'll say, okay, it's time to hit the charger, and start sending the voltage from the input to the output, which is our battery pack via the shunt and the main contactor. So as it starts doing that, we can interrupt that signal using something like the AVC2 in one of the relays here. So the pedal interlock relay, also known as the drive-away relay, is the one that exists to let you know that to keep power from the motor anytime the charging port is plugged in. So you cannot drive away while your car is plugged in. That's a really good safety feature. Very nice to have. Then you have your low voltage cutoff relay and your high voltage cutoff relay. The low voltage cutoff, it's here. You get the signal from LP2 on the BMS, and with the diode, you can also send the grounding signal through pin 85 to the high voltage cutoff relay. I've already got a couple of Bosch relays on order. I went ahead and used the Bosch number that they recommend because it's a reputable brand. It's a relay that I hope will last 15 years. So the low voltage cutoff will have a warning buzzer. EV West does sell a nice little LED for about 10 bucks. It's got a buzzer, it's got a light. You could wire the existing car oil pressure light or the battery light. Sometimes they're small, sometimes they're hard to see, sometimes they're just full of dust. So you want something that you can audibly hear as an alarm, because this is like the oil pressure light in an internal combustion engine. If it's on, damage has been done. The life of your battery pack will be reduced if you have hit your minimum voltage. Now, EV West also has recommendations here. This is a quick start guide for the BMS using the 5.3 kilowatt setup, which I think is 5 battery modules. We've got 7, so it might be a little bit different, but we'll go through this later. But it's going to give you some parameters for how to program your BMS and where to set your parameters for high voltage cutoff, low voltage cutoff, and then the clear. So, for example, if our high voltage cutoff for the BMS, remember that's our airbag safety system, it's not the stop charging voltage. This is the we've exceeded and something has gone wrong, so it really needs to emergency cutoff. This is 4.15 to 4.2 volts, which means that our charger needs to be hitting less than this, because if the BMS is signaling the charger to stop charging, it's going to be very abrupt. And it's not recommended to use the BMS as your on-off for the charger, so you want to make sure that your charger is programmed to the correct amount. When we're first testing this, I will set these parameters a little bit lower. If our optimum battery voltage is about 4.15, I'm going to set my high voltage cutoff to 4.10, just to make sure that what I've done here is tested and working, and then I can go ahead and set it to the 4.2 when we're just driving about. All right, and just the same thing for the low voltage cutoff. I want to make sure the warning buzzer and light works, so I will test it with a slightly higher limit, not the low limit of the emergency rating, but just a little bit higher. All right, so this one is pretty much understandable. The loop here is another point of confusion for a lot of people, and I was talked through it on the phone, which is very nice to know. For example, this here, pedal safety interlock, it's part of a loop, but the loop doesn't just finish here, it goes to wire number 1, signal ground. So the loop would essentially continue here to here, back to the black. There are 3, I think it was wire 1, 9, and 12 are all grounds on our controller. So they're the input-output grounds. Number 1 is also repeated here as the signal ground for the regen power button and the throttle pedal. So that's interesting. We're gonna have a couple of options for it. I think that's all pretty much covering this entire page. My BMS is gonna get 12 volts. It's gonna have that 12 volts every time the ignition is on, but with the diode, I'm making sure that it's also getting 12 volts through the AVC2 once the AVC2 detects a charge. Boom. And then again, as that charge is detected, it will trigger this relay so that we can't drive away. That interlock stops power to the motor. These diodes are very useful for something like that, where you need power in 2 different situations, but you don't need the power sort of back feeding this way, so it stops it. And I'm really hoping that these are reputable diodes, these 1N4001s. Got a pack of them floating around here somewhere. We're gonna wire them in place, and fingers crossed that everything works out nicely. We have all of our safety systems in place. And as I understand it, the charger interlock loop is the 12 volt trigger for my non-CAN charger. That's the one that essentially plugs the charger into itself, because that's what really matters. It just needs a 12 volt signal, and then the rest of the charging stuff is done through the high voltage side. have a better understanding of how some of these circuits work, the trainer cart schematic is really nice because it does show you this is the interlock relay there, and you can follow all the wires very clearly labeled throughout the whole system. This is the AEM display, and you can use that to replace your gauge cluster. The TBS state of charge meter is the best for like keeping a simple, clean look. And if you do want something like a light that triggers while you're charging, the state of charge meter shows you through the orange light on the screen that current is going in or out. So when you're driving, the screen's on, and when you're charging, the screen will turn on. So that's a nice little indicator of how you're getting power to it. And then another thing to consider is here's the EVCC. This is Thunderstruck motors, and it can replace things like the BMS and the AVC2. It's like an all-in-one unit, which is quite nice. That's the way I understand it, and I hope I'm not incorrect on that. You can see this one in the store if you go to visit EV West, but it kind of gives you the fundamentals of the system. It's not that complicated when you have just this to look at. The better I understand it, the easier it seems to be. I'm ready to get off this chair and get back into wiring. Crawling under the dash and seeing if I have room for all of these in my already full contactor box. I was really running out of space to get the AVC2 mounted with the additional 3 relays. So I've gone ahead and made a little bracket that'll bring it out forward a little bit. So it's got double-sided tape on it because I couldn't get the bracket all the way across without interfering with this relay. We're making things work. We're getting layered now in a way that we weren't before. But that's okay because it gives room for all of our cabling here. These are all the wires for the high voltage cutoff relay. I'm waiting for my other 2 relays to arrive. And when they're here, everything should be nice and buttoned up. And then I can put some new labels on things because I love labeling so much. About 2.5 hours later, the trio of relays is wired. It's labeled. There's a diode installed right there between 2 of them. And I have an additional set of wires running to power these back through the firewall. You know, when you think you're finished running wires through the firewall, there's just another 1 or 2 things that comes up. So the loom is right here, blends in nicely with the rest of these, and while there is quite a bit of loomage happening, it's all black, it's all mostly concealed, and the drama is lurking behind a few things that you don't really get to. It's not too much of an eyesore, I think is what I'm trying to say, because it is mostly contained to just running along one side there. A lot of wiring when it comes to these electric cars. Go figure. The diodes have a little stripe on them, and that's the cathode side, which is towards the negative. The anode is where the power comes in from. And yes, the light emitting diode is essentially a one-way check valve where the result is light. So this is what a diode looks like. It's very tiny, and it comes with bare sides, bare metal exposed on both ends. So I made sure to note which side was the mark, and that's the cathode side. So that's the side that goes towards our devices. That's the side with the line. So it's a very simple way. Just wherever that straight line is, that's where the striped portion is of our diode. And in this case, it's heading over to the BMS controller. It takes 2 power sources, one from the AVC2 to power this, and then the other one is from the ignition switch. Yeah, it barely fits everything the way it is. And the last thing I'll do after I make these connections is try to find a space so that the wires don't just bounce around, and make sure it's all safely zip tied and still somewhat serviceable. I sure am learning a lot of lessons for car number 2 on how to design the interior of a contactor box to maximize the efficiency. Loops are finished. It's 2 days of wiring to get all this stuff in and routed. And basically underneath where I'm sitting, they've got all the connections that go over this way into the BMS. The connector up here at the BMS, that little guy, you tin the wires and then you just push them into the terminals and they fit in nice and tight. So that's good. I didn't have to do any fancy crimping, but I did mess up the connections between 1 and 2, so it's a little tricky to get them out once they're in, so make sure you get them in on the first try. This is not something that I'm really proud of the way it looks, because right now it's a little scary. It got a lot more scarier with all of this, but it's all labeled, so I'm feeling pretty good about how this went considering what we had to work with space-wise. And then I ran the pilot and the proximity wires from the J1772 through here. Everything that you can see goes over there to the carpet, and then that loom runs underneath. goes all the way down along the way to the back and ends up right here. So yeah, it's quite a bit. There's service loops on everything. That's why it looks kind of loopy. And that's just in case I need to lengthen something later. But I think I'm ready to go hang up my flashlight and call it a night. Charger is installed. Gonna do some wiring to it and it's ready to test. So I've now run the wires from our high voltage cutoff relay. That's the yellow and the white wires, and there's labeled as charger interlock loop 1 and 2. There's a 12 volt enable wire, which essentially comes from one plug of the charger, loops around this blue and white / black wire, and plugs into another port in the charger itself. So here it says 12 volts supplied through white and blue wire to mating connector gives the enable signal. BMS can open circuit to pause charging. But in case there's a problem, the car continues to charge the batteries, we have a high voltage cutoff. So I'm going to take those two wires from the relay, our yellow and white, and essentially I'm going to cut into this blue and white cable and one side of the yellow here, the other side into the other side. So if there's a problem, the relay, which these are wired right now to the normally closed side, will switch the contact over to normally open, and that means that it will disconnect the charger abruptly. Again, we don't want to use this as our signal for when to stop charging, only for when to stop charging in case of emergency. It's another new day. It's now the end of April. I wanted to have the car done, well, last May, but then every time we reach this point, it's like we're at 90%, and I go, I think I just need one more month. And there's a couple of delays, things that come up. People have to go to emergency rooms. People need a ride from another part of town because their flight was canceled. Whatever that kind of stuff is, just life. Life things happen. And then the battery brackets have arrived today, so progress is being made. Let's do some test fitting and check out Soren's work. Looks great. It's amazing. Battery brackets are here, and wow, Soren's amazing. Look at this. Huh. It'll be pretty light. It's going to be 165, 170 pounds of weight inside of here. So this should fit underneath our steering components and battery tray. And then on that side, that's going to fit underneath the vacuum canister, that little notch there. And he boxed everything in like that. Look how nice this is. So let's weigh it before we put it in the car, and then we'll do a test fit and start making any necessary adjustments. The small side brackets are now on, and I have some idea of how I want to bolt this up. What I think I'm going to do is, since the batteries lie in this way, and you can get an idea of that by looking in here. Okay, we have 6 holes already. 2 of them I've made larger for the cables to go into the front. The third one down there would be a bolt hole, but since the bracket is a little bit further this way, I can actually just put the bolt holes in the bottom of this piece. Blue line here is where the battery modules end, so I have all this space in the front to work around. And then for the back side, I can do a couple of bolts through here. I'm thinking about doing 2 up top, so 1 and 1. Because we have the plastic liner on the inside, I can stick any bolt that has a head smaller than this. This is a giant bolt, and the head is still a little bit tinier when it's flush there. Got about 2-3 millimeters, so that means I can go with something a little bit smaller, like a 7/16 bolt, and that should help cinch it up pretty nice, and then have space for the batteries and the plastic liners. So that'll be good. I like to see this. I think the best decision I made for this was putting the bracket in the front to kind of hold this in place. Very nice. knew I was gonna need this laser level for something. Plotting holes here for the bolts that we're gonna be putting through the brackets. Another day, another couple of hours of progress. You know, I thought May was gonna be kind of a calmer month. I tried to clear my schedule, but oh boy, do things pick up. Drama, family, birthdays, work, other stuff, acting stuff, etc. You can read all about that on Patreon, but here we're just gonna discuss more and more how the box is being mounted. Okay, this is my third day now, and I think I've got it kind of bolted down correctly. I'll show you some of the things that I was encountering along the way. Phew! So this thing came out like 12 times probably, because I started with smaller holes so I could do like, I didn't want to buy too many of those long drill bits because they cost 20 bucks a piece, you know, to get a foot long drill bit. And we needed about 11 inches to get through all these surfaces. And I don't want to go larger than 7/16 because I don't think I have the real estate for it. There's some weird angles to the bottom of this bracket, so I put the bolts as far apart as they could be while maintaining the same like level portion of the bottom of that bracket. It's looking pretty good now that it's covered up, but I'll tell you, underneath this side, there's like 4 holes in the car, and that sucks. But there's only 2 in the bottom, and that's what matters. 2 at the top, 2 at the bottom. This side was just 2 and 2 all the way through. Okay, so I'll put the box on now. We'll check our levels on it, make sure everything's nice and tidy, and then I can go ahead and pull these out, paint them, throw them back in tomorrow, and get hardware that is the correct size, because you know, third time's a charm when you're sizing things. Remember when computers was so big, dude? Yeah, when I was a kid, basketballs were pretty big too.